Okay, in this quick little video, I want to sum up the key idea from the lab that you did on power and resistance and talk to you why or how you would know in the future what equation will give you the correct relationship. I mean, it's really all about what stays constant and what doesn't. So let's recall. We know that we have power is either voltage squared divided by resistance, or it can be calculated as current squared times resistance. And we pointed out these seem to give contradictory relationships. And then when you did the lab, you found it was this one that worked, so P is inversely proportional to R. Okay, and that's not immediately obvious, okay, but essentially the idea is more resistance means more current. More current means you're going to get less power delivered, so that's why it's an inverse. So I want to show you why this can still be used to get the correct proportion. It's just a little trickier. So before I do that, let me remind you, if I'm going to draw this graph, if I'm going to just relate P versus R, everything else must remain constant. So in a simple circuit, right, if you recall in the lab, you change the resistance, R. You didn't change the voltage. So if you didn't change this, then this is the relevant equation. And when you did change resistance, you necessarily changed the current. So as you were changing R, I was changing, so you can't just simply relate P to R and say it's linear because current is changing. So that's the conceptual idea. So when you go to choose an equation, you choose the one with the two variables, and if there are two equations that have those sets of variables, then you choose the one that's staying constant in that situation. Normally, voltage will stay constant. You might ask, is there a situation where I can change resistance and current stays constant? Yes, but that's a little bit more complicated and we haven't learned that yet. But I'll give you the spoiler, it's a series circuit. Okay, so let me show you how I can still use this equation if I'm clever. So let's say I've got twice the resistance compared to something. And according to this upper equation, we know that's going to give us half the power. Okay, how can I show that here? Well, I'm not going to just do a substitution. Well, I have to take that back. So if I've got twice the resistance, so I'm going to put my new P prime is going to be I squared R, and you might think, all right, what's this I squared times 2R? And that would seem to give us twice the power. But I got to realize that current is changing. So I got to make an adjustment for that. So if I know that current is V over R by Ohm's law, then I'm going to put V squared over R squared times 2R, right? That's my new power. And there's my new one. So I got to put in the 2R here. So I'm going to have the same voltage, 2R quantity squared times 2R. And if I work that all out, I've got a V squared over R, which is just my original power, and then the 2 divided by 2 squared is 1/2. So in other words, I've got 1/2 the original power, which is the same as this. Okay, so just want to make that clear in regards to the lab.